All right, folks, welcome tonight. This is Tech Talks Drone Technology. Thank you for coming out on a rainy evening. Our goal for this series is to share firsthand information on emerging technology innovations that are happening here in Washoe County. Thanks to our guest experts, we get to learn, ask questions, and consider the possibilities of what this technology can do. Tonight's topic is drone technology. We've all heard stories about how drones will deliver goods, supplies, even pizza, as well as save lives, inspect power lines, fertilize crops, or serve as a weapon in wartime. According to Precedent Research, global commercial drone market in 2021 was $24 billion. That's expected to grow to over $500 billion by 2030. That's millions of commercial drones in our skies. But there's so much to figure out in terms of safety, propulsion, regulation, power between now and then. And we have some of the leading experts in the industry here tonight that are going to figure that out. Mark Genung is Vice President of Operations at Iris On Board, based in Reno. He has a master's in I'm going to give you a short bio, and I'm really underselling the vast experience these folks have. Mark has a master's in systems engineering. He's a Navy veteran with over 30 years of service, including commanding warships and working with unmanned aircraft. While at Flirty, working with Matt, now SkyDrop, Mark worked to achieve the first FAA-approved business home deliveries, as well as shore-to-ship-to-shore deliveries. With 10 years of experience in the industry, Mark is responsible for the testing of Iris automation software, Kfcsc. That's it, right? Kfcsc. Detect and avoid technology. Nishu Varma is Chief of Staff at SkyDrop, with a primary focus on providing program management to lead the drone delivery technology roadmap. Nishu has over 15 years experience directing large-scale transformational initiatives. Nishu also founded Neve Incorporated in 2011, with the vision for businesses to receive the highest degree of value from project and program management. Nishu has worked with organizations across the public sector, as well as in life sciences, healthcare, financial, manufacturing, and high-tech industries, and helped them achieve operational and strategic objectives. This is Matthew Sweeney. He is the CEO of SkyDrop, formerly Flirty, a provider of hardware and software for autonomous last-mile drone delivery. You can see that on the table right there. While studying economics on a scholarship in China, Matthew began developing a technology to deliver goods faster and more cost-effectively. He then moved SkyDrop to the United States, where he received his education from Y Combinator, one of the foremost startup accelerators in the country. The company has worked with NASA and top universities, and first made history in 2015 when it conducted the first ever FAA-approved drone delivery in the US. Carlos Cardillo, PhD, serves as the Executive Director for Corporate Partnerships at the Nevada Center for Applied Research. That's at UNR. And he served as research director in startup companies in Reno and for the Department of Defense in Fort Rucker, Alabama. Carlos has developed, implemented, and successfully executed large research programs sponsored by the U.S. Department of Transportation, as well as the Department of Defense, amongst many others. Thank you very much for your time and for coming up to share your expertise with us tonight. So I'd like to start with Mark. I'm going to ask each expert to speak for about 10 to 15 minutes on their area of expertise or what they think you should know about drone technology and what's coming down the pike. And then we'll open it up to some questions. We also have in our audience, John Abbey. The name of your company, John, is Skywatch? Safe Flight. Excuse me. I'd like to hear a bit about his work as well. But we're going to start off with Mark. Please come on up.
Thank you. Well, again, Mark Genung, VP of Operations Iris Automation, and as John alluded to, I've been in the commercial UAV industry for 12, 13 years, and I really got my interest in it when I was operating warships at sea and doing helicopter operations, which in many ways are an extension of my weapon systems and sensor systems. Realized that there was a great opportunity for commercial off-the-shelf drones to be able to augment the helicopter detachments. And so I decided to learn to fly those systems and eventually took, if you will, that hobby into a next career, because our industry is brand spanking new, as Matt and Carlos will certainly amplify. So if you can, let's see, there we go. So ours automation, our fundamental focus really is aviation safety. And you're going to find, quite frankly, that there are different companies doing different things within the world of the drone. We don't build drones. We enable drones to be able to fly beyond the sight of an operator on the ground, because the FAA has specific requirements that they impose upon us for operation. So next slide. And so again, we're fundamentally to ensure this, right? Because there's a great quote from like 10,000 or several thousand years ago that a collision at sea will ruin your day. Well, so will an air-to-air mid-air collision. And so that's what we're here to prevent. And so the next slide, the FAA has specific guidance on how they think this happens in the manned aircraft world. And basically they have regulations that basically say when weather conditions permit, I should note I'm also a private pilot, about 220 hours, and a remote pilot several thousand hours, is that somebody within a cockpit, the pilot in command, is responsible for looking outside the windscreen, understanding his or her environment, orient himself. When he sees another aircraft, maneuver that aircraft in a manner consistent with the rules of the road, which in many ways are like driving a car. Two aircraft head on, they both turn right. One aircraft is overtaking the other, it turns right or left to avoid a crossing situation. Think about going to a four-way stop. The car on the right gets to go, and then the car on the left gets to go. In this case, the airplane on the left gives way. And all these regulations presume a qualified pilot looks out to the window and sees these things. But really, how good is a pilot? Next slide. And it turns out that the way pilots do this is when they fly along, they basically divide up in their field of view different quadrants, and they scan each one, and then they look to the next one, and look to the next one, and look to the next one. And you can see in this example, I'm not looking over here. And so it could be upwards like 20 seconds before you go back and revisit a certain area within your field of view. And if you go to the next slide, what drives this is because while the eye is an incredibly fascinating organ, but if you're all looking at me, you probably, as you think about the slide a little bit, you realize, well, I really can't read things much further than my arm length on either side of me. And you might be able to, out of peripheral vision, understand what color jacket whoever's sitting next to you is. But you only have that really acute understanding and great visibility and ability to focus and understand what you're seeing in a very small arc. Next slide. And so that means that because you can only see in this very narrow cone, that's why pilots divide up the world and look at it that way and do that scanning action. But yet the regulations are predicated upon the fact that a qualified pilot is looking out to the window, doing that kind of scan, recognizing and seeing other airplanes, and making decisions consistent with what he sees the other aircraft doing. Next slide. Well, how good are pilots? Well, it turns out not really the gold standard. There's a great joke out there that basically says the most likely time a mid-air collision is going to occur is going to be on a Sunday afternoon, on a really pretty day, next to airport, flown by two retired dentists. Okay, and that's the joke, but the truth is not far from that. We're talking about the average experience of pilots, something like 5,000 hours. Flying in VFR, visual flight rule conditions, near airports. And you go, well, how could that possibly occur? Well, one typical example is if the runway's ahead of me, and one plane's coming straight in for a landing, and he or she doesn't talk too much about the radio. I got another plane over here doing a racetrack turn, and they're on a base turn, and then they eventually turn the base turn to final, and they're not talking or looking. This guy is very concentrated on where the runway is. This guy over here, he's very concentrated on where the runway is. Nobody's concentrated about where this plane is relative to him. And I'll be candid, when I'm on the base turn to final, I don't hear anybody out there. I'm sure not looking to the left. We have collisions like this all the time. So, next slide. So the intent of Kfcsc was to build a technology that doesn't get bored, doesn't get frustrated, doesn't get hungry, doesn't get angry, doesn't get sleepy, and then basically a constantly looking eye that looks out into the world and recognizes other aircraft. Now, I should note that this is the totality of what's going on here. All the operations occur on board the aircraft. There is no video feed that's going to the ground for somebody with we talked about all those narrow vision focus things, issues you have, plus looking at a monitor and all that. Nothing gets pushed to the ground. All the computations occur on board the aircraft, in this case of a drone, or in a ground-based application we'll talk about shortly on that ground station. And so we use techniques we call machine learning to enable the system to look at the pixelated world and recognize a plane. Now, I don't know how many people know much about machine learning, but let me give you an example about my daughter. When she was 2 or 3 years old, I gave her a book of animals, and I turned to a page where there's a lion. And she would say, kitty cat. I said, no, that's a lion. See the big paws? Oh, okay. I turn the next page, there's another picture of a lion. She'd go, kitty cat. No, that's the back of the lion. See the poofy tail at the end. Turn a third page, and she'd say, kitty cat. Again, another lion. I said, no, that's a lion. Now you can kind of see the mane and some of the other features. And so by about the 4th or 5th picture, my 2 or 3 year old daughter could look at a picture of a lion and almost any lighting scheme, any background you could think of and go, lion. Because my 2 or 3 year old daughter is a lot smarter than our silicon wafer chip. So we have to do something in order of hundreds of thousands of examples of airplanes to teach our system how to recognize what a plane is. And so we've done that by, in the last 4 or 5 years, something like 15 or 16,000 intercepts, where we fly drones, much like this drone here, in near collision intercepts with manned aircraft that are also flown by my pilots. And by doing these near collision intercepts, 250 feet in the vertical, 150 feet in the horizontal, we then get all these wonderful examples of what different aircraft look like in different lighting conditions, different target angles, to enable our world-class vision engineers to be able to teach our system that with something over at about 96% accuracy, if I see this set of pixels, that's an aircraft. That's the hard part. Now that I recognize that a set of pixels are an aircraft, now it's trigonometry. I can start doing things like calculating course and speed and where it's going and what is the risk to the aircraft, the drone. And in full auto, our system can enable an autopilot to do an avoidance maneuver just in the manner we described about what aircraft do. Turn right or left, turn right. Next slide. So over the years, what we've been doing is now enabling aircraft to not only see what's in front of them, but all the way around them. Right now, by regulation, drones must yield right of way to manned aircraft activities, regardless of the incident angle. And there's a good reason, because small drones are hard to see. It's very hard to, you're in a Cessna 172 to see a drone that's 1 meter across, that's flying at 25 miles an hour, while I'm flying at 80 or 100 miles an hour. So to meet that requirement, we've developed a family of systems, Kfcsc, and they give you a sense of the size of it. It's still relatively hefty for a drone, but this is the graphical processing unit that takes up the feed of 6 cameras. Each camera has a field of view on the order of about 80 degrees in a horizontal, 50 degrees in a vertical, and does the computations and can recognize when it detects another aircraft. And so with that technology, then the drone can then fly beyond visual line of sight of the operator and do that safely. And we have done that. Iris Automation has had FAA approvals under the Arena Beyond program to do exactly those kind of operations with this 360-degree system. Look, Ma, no hands. Or in this case, look, Ma, nobody's looking at the sky to see if there's another aircraft there. The Kfcsc system was doing that and enabling our operators to fly those missions beyond visual line of sight. Next slide. But we have great customers like SkyDrop and customers who want to do drone out of the box operations that needed a different technology. So this is not my drone. This is a Mavic drone. But there are companies out there basically have magic-sized drones or equivalent size, and they have them in a box. And the box stays out in the field, got an enclosure that comes over the top of it. And the concept of operations is that an operator 500 miles away says, "Oop, time for my weekly inspection." Or if I'm Florida, like Florida Power and Electric just announced a relationship for Percepto. By every substation, I want to build a drone in a box. So when a hurricane comes through, and after that occurs, I can immediately launch these drones to do what we used to call in the military, the dull, dangerous, and dirty work of drones, to be able to fly and find where maybe there's some damage. And now instead of people searching for damage, people are immediately vectored to the source of the problem, and it can immediately affect repairs. Again, as John alluded to, the whole part, the element of one of the industries really is important to us is to save lives and improve the quality of lives of those we serve. And so with Kfcsc ground, we have that capability. So this consists of 360-degree field of view, again, a processing unit. But instead of now talking to an autopilot, we push the information to the cloud, where now a ground control station operator who's operating his or her drone can directly see our detection feed. Now they have great situational awareness to be able to safely fly that drone beyond visual line of sight and do these missions we've alluded to. Next slide. So what does Kfcsc? It basically sees the pixelated world and can recognize that a pixel and put a bounding box about it and recognize that that's an aircraft. We can also detect birds, and because, well, heck, we just had the Reno air races, the balloon races. We collect a lot of data for balloons because we have customers who operate in like the Napa Valley region, where there's routinely people having their champagne balloon rides and want to fly drones, again, from a box. So we're even doing data collection at the Reno air races, which we've done for the last several years. And while we can't necessarily figure out that that cow is a balloon, we're very good at recognizing that the basket underneath it is part of a balloon. And so it's very interesting because sometimes we're not quite entirely sure what our machine vision technology recognizes as an aircraft, what elements does. I mean, how do you recognize a plane? I think I see wings. I think I see a fuselage. I hear an engine. You know, some of these things we take intuitively. The machine learning system figures that out on its own after we give it enough examples. Next slide. So one of the challenges we've been asked and be involved in is the Reno Beyond program. Now, the Beyond program is an FAA-sponsored program, started out as the interoperability pilot project. And the intent for the FAA was they identified a number of sites, including Reno, to basically solve problems about how can you safely fly beyond visual line of sight or be able to do operations over people. And one of the challenges in Reno is, of course, the Truckee River. You're all familiar with it because you live near the source. And the Truckee River flows through downtown Reno, which has a high population density. And next slide. And a routine problem they have is they get reports all the time that somebody has fallen into the Truckee River. Now, as I alluded to before, I commanded 2 warships, served on 8. One of the scariest things you can imagine in the middle of the night at 2 o'clock in the morning is man overboard, man overboard. And if it's heavy seas or rough weather, the CO has to make really hard decisions about, do I truly have somebody in the water, or did somebody throw some garbage in? And so you're getting everybody up, you're getting everybody mustered, you get everybody accounted for. Meanwhile, you're maneuvering the ship, you're launching helicopters, and you're preparing to launch small boats as necessary to save lives. The fire department has the same problem. I've got to report somebody in the water. Is there truly somebody in the water? Do I put people at risk in cold, rushing water to go look for them? And if I had now a system to be able to immediately deploy a drone, I could potentially find out where people are or maybe are not and make better decisions about when I'm going to put people at risk to save lives. And so, next slide. What we're doing is we're working with the city of Reno to basically put up a series of Kfcsc ground stations along the Truckee River to enable testing to be able to use drones to save lives. So one of the things next slide, one of the things we do routinely in the aviation world, drone world, is a so-called crawl, walk, run, fly approach. Take the problem, break it down into small bits, figure out what you can do safely to build upon that, and then give you the confidence to move forward. So instead of, right now we're doing testing at the Kfcsc River. Why? Well, there's no peoples there. There's lots of cows. It gives us much of the same kind of environment that we can test and prove out our technology. And so that's what we're doing now. And we have been doing this work with the city of Reno, and there's a number of press releases already out on that. And our next phase of operations is testing with multiple Kfcsc ground nodes to have a drone do simulated search and rescues along the Kfcsc River. And if that's successful, then we'll work with the city of Reno and with the intent of working with them and the FAA to get approvals to then do this on the Truckee River. So again, at Iris Automation, we're fundamentally focused on solving the problem of how can drones fly beyond visual line of sight of an operator in a safe manner, so that great companies like SkyDrop can do what they do best, which is to deliver goods, to save lives, improve the quality of lives of their customers. So pending any questions, that's all I have. Thank you.
Why cameras and not radar or some other?
You know, that's a wonderful question. There's a number of modalities we could have taken advantage of. So everybody knows what an iPad size is, right? So typically right now, where the state of the art is, a radar that's about iPad size, but maybe 4 times as thick, gives you maybe 120 degrees field of view. So I need 3 of those, and if you talk to the vendor, they say 4, to give you a full 360-degree field of view. Right now, the price point of one of those is around $30,000. So that's $100,000 to $120,000 of radar, and you haven't put that around a drone yet. It's a clunky form factor. Takes a lot of power. And so radar is not a great modality. Another one could be LiDAR, right? That sounds really sexy. The problem with LiDAR is it only has ranges on the orders of hundreds of meters. And you want to be able to detect aircraft much further out, so you have sufficient time budget to be able to do detection.
Are you limited to VFR rules in cameras?
Well, yeah, exactly right. And because we're a visual medium, so VFR rules. So we need a minimum visibility. But in fairness, most drone companies will fly in VFR because their sensors need to be able to see what they're doing. Now, there's going to be cases when you're saving lives and other things where potentially you would fly it something other than VFR. And again, we're not the perfect solution when I have to fly in those situations as a private pilot. Then I have to go to IFR rules. I'm flying under the control of an air traffic controller who's using other sensors to safely help me navigate my aircraft.
They have a requirement for a transponder, and I have to have a transponder on your particular vehicle.
Currently, the FAA does not require, in fact, they don't want you to have transponders or even what's known as ADS-B out on drones. They have a requirement that's coming out called remote ID that will come into play.
And folks, we're going to open it up to more questions in discussion after each expert speaks.
Yeah, I'm sorry, I probably didn't mention that.
No.
I was in my end of speech mode.
We're chomping at the bit.
Certainly.
Yeah, you speak next.
Want to go next?
I'll give an
Whichever
overview
you
of the
prefer.
company and then you can.
Okay, you go ahead. Yeah.
Does the camera turn? Can I sit?
Absolutely cool. Please go ahead whenever you're ready.
Okay, hey everyone. G'day everyone, and thanks for spending your evening with us. My name's Matt. I am the founder and CEO of SkyDrop. Little bit of background on, I guess, how the company got started. I went to the University of Sydney in Australia, got a scholarship to live and study in China. In my dorm room, I remember thinking, like, wouldn't it be better if we could have on-demand delivery of food whenever we want it, instead of having to venture out? And then when I ventured out, I went to the electronics markets in Shanghai and saw model helicopters starting to go on sale. And I looked at that technology kind of, which was in, the earliest phase of the drone industry. And I tried to think about it from first principles. If these little helicopters can fly a camera, what else could they fly? And so when I thought about it from that perspective, it became really clear to me that there's a core value proposition here, which is that drones are the fastest, the speediest way of delivering a package, because they fly as the crow flies, they don't get stuck in traffic congestion, it really enables a world where we can have instant on-demand delivery. Second is that drones are the cheapest form of delivery, because when you think about this technology scaling, right now you have a person get in a car and drive a package to a destination. Well, at scale, you could have 100 drones delivering packages with one all flying autonomously, with one remote human operator just on the loop, overseeing that autonomous software. And so if you think about it, even just from like a financial perspective, if someone's being paid $15 an hour to drive a car and deliver packages and they do 2 deliveries per hour, well, it costs $7.50 in labor, okay? But if you're paying, say, a remote drone operator that same $15 per hour, and each drone can do 4 deliveries per hour and they're overseeing 100 drones, well, now you're down around 3 or 4 cents per delivery instead of $7.50. So there are just massive cost savings and higher margins to be generated by operating autonomous drone delivery over traditional on-demand delivery. So drone delivery is speedier and it's cheaper, but it's also greener. For every package that we deliver by drone, compared to a gasoline-powered vehicle, we reduce the greenhouse emissions by about 86% per delivery. And then when you model that at scale, in round numbers, it's equivalent to about taking 1 million vehicles off the road. So the core value proposition from first principles of drone delivery is speedier, cheaper, and greener delivery at scale. And so I set about to kind of build this company. I remember at the end of my time in China, I'd bought 2 model helicopters and I'd bought, all these clothes on exchange, and I only had 1 suitcase. So I threw out all my clothes, brought the helicopters home, and kind of got started with this vision to build the company. And I moved the company to America because we wanted access to the top engineers in the world. We wanted access to investors in Silicon Valley and Incline Village. And so we then, I remember our first office in America was on campus of the University of Nevada, Reno. We hired graduates out of the drone program at the University of Nevada, which was one of the first universities to have a drone program. Many of those early hires are still with the company and have really kind of been core to building out our technology. We went through Y Combinator, where I kind of got educated on the business side of running a startup. And then we hired the head of NASA's drone program. And so that was a kind of a really key decision that we made, because NASA Langley had spent a lot of time researching drones. And so we pulled that research in-house, focused on commercializing drone delivery. So then over the years, we had a series of milestones. We were the first company ever approved by the FAA to do a drone delivery in America. We did the first commercial drone delivery to a home. We did the first ship-to-shore drone delivery. We then ran the first regular commercial drone delivery service. And from those commercial operations, what we really managed to do is collect a lot of data about the characteristics of a drone that is needed for commercial viability. And you can see our SkyDrop Eagle over there, which can carry 8 pounds of customer cargo, which is more than 3 times more than Google Wings program can carry. It also has a much larger cargo bay size, and it's designed to hover and lower a package out of the air from 200 feet, which is almost 10 times higher than Google Wings program can deliver. And so what we've built is a commercially viable autonomous last mile drone delivery system. And earlier this year, we signed and announced a deal with Domino's International. We also then got nationwide regulatory approval in New Zealand for commercial drone delivery. And those regulatory approvals are ahead of anything anyone has in America. And so I feel like we're right on the precipice of the widespread emergence of the commercial drone delivery industry. And we're right at the forefront of it, with Domino's, who's the dominant player in on-demand food delivery in our, internationally and in particular in our launch market, New Zealand. And we're about to launch regular commercial drone delivery. And I think that combined with Walmart's plans to expand drone delivery to more than 4 million homes in America by the end of the year, Amazon's announcement that they're about to launch commercial operations. I think that we're right on the cusp of the next big industry, and I'm excited that we're at the forefront of it. So that's kind of a quick snapshot of SkyDrop. Be happy to answer any of your questions and dig deeper into anything that you'd like to know. And from the early days of the company, we've been working with Nishu, who was, initially our program manager and then became our chief of staff, who sort of oversees the development program that has resulted in the SkyDrop Eagle and this imminent launch with Domino's. So over to Nishu.
Thank you. I think it's always nice to hear from the founder himself on how the company started, right? Because when I first found out about SkyDrop, one of the early investors actually at SkyDrop reached out and said, hey, there's a company called Flirty, and they're working with drones. As we know, Flirty is now renamed to SkyDrop. It was enough to catch my attention. 2 words in there, Flirty, and then drones, right? So we are all here today because this is a new technology that is definitely catching all of our attention. And as you mentioned, I had worked extensively across different industries. I was fortunate to have worked with FDA in the clinical research industries to see how drugs are researched and save lives over there. And now to take that element of saving lives and bringing it to another element of technology by being able to deliver medical supplies or AEDs to customers that need it, in addition to food delivery, contactless, which is a huge, I mean, we've all gone through the pandemic, right? Contactless food delivery. How many times have we heard that word? Thousands of times, right? So this is the technology. This is where we want to be. And that's why I have been on this journey with Matt and with SkyDrop. And, in addition to what Matt shared about the company, if I may focus a little bit on our drone right here, the key part about SkyDrop's Eagle is that it has been built with not the requirements that I generated, or for that matter, that Matt generated. Those have come to us from the customers, from food delivery customers. What are they looking for? It's not enough to say, oh, I can deliver food to you, but I cannot deliver more than 1 can of soda. What use is that, right? So things like that, being able to accommodate and understand the requirements of speed, of weight, of safety, and then designing the product around that. That's been a pleasure to work with the team at SkyDrop. And so what this drone has right now is we can, like Matt mentioned, we can deliver 1 full meal, right? So about 8+ pounds. And another thing that has taken us time, but that we feel proud of, is that this is equipped with a parachute. So safety is very key and very paramount in all our design discussions. So as much as there's the whole commercial end of requirements, there's the safety end of requirements, and then there is the regulatory end of requirements, right? Where IRIS plays in, where we have to consider things like being able to fly non-visual line of sight and working with FAA on those kind of requirements. And so that's what I have been driving and working with SkyDrop and team on, is being able to meet all those requirements. Why did the word drone catch my attention even early on? Yes, we're doing drone delivery for food, right? Like we all raised our hand, a contactless food delivery. But I lost my dad at a relatively young age due to a massive heart failure. And till today, every day that I work on this technology, I think, could an AED delivered in time have saved his life? Maybe, maybe not. I don't know. But we could save many other lives. And so as we look into this technology, we have the commercial aspects, the life-saving aspects, and all of those are being considered when we have created this design.
So I'm going to take a different approach. I'm going to just give you general information on what we do, on where we're going with the Nevada Center for Applied Research at the University of Nevada, Reno. They presented technology. I'm going to focus on what is now called Nevada Autonomous, which is the FAA test site operator for the state of Nevada. Now, before I explain more about Nevada Autonomous, next one, please. I'm going to talk a little bit about the Nevada Center for Applied Research, which is a center at the University of Nevada, Reno, that is sponsored by the Governor's Office of Economic Development. And the goal is to be a portal for industry to access university resources. And here we're talking about anything from mechanical engineering, robotics, civil engineering, biotechnology, and anything that the university can provide as resource assets that will be labs, equipment, or intellectual capability. So the goal of the Nevada Center for Applied Research is basically work under what I like to call the triple Helix model, which is collaboration between industry, academia, and government. Now, how we do that? Basically, we are always government because it's sponsored by GOED. We are always academia because we are part of the university, and industry is always the group that is coming and trying to access resources so we can work with them. In my role, I'm not only the director of the Nevada Center for Applied Research, but the director for corporate partnerships at the university. So we focus on bringing all these collaboration that is beyond academic. So we do academic collaboration, but this is corporate engagement that we're looking for. Now, if we go to the next slide, please. What is Nevada Autonomous? I'll give you a brief history on what NIAS used to be. NIAS is the Nevada Institute for Autonomous Systems. NIAS was in Las Vegas up to about three and a half months ago. And the governor's office decided to make a transition, and NIAS is no longer the test site operator for the state. And basically, Nevada Autonomous under NCAR and UNR became the test site operator for the state. Now, the test site operator is one of the 7 sites in the United States that work with the FAA on what mission? Conduct FAA contract in support of integration of UAS system into the national airspace. And that's basically our main mission, which is the mission of all these test site operators in the United States. So we focus on unmanned traffic management systems and creating an ecosystem for all autonomous vehicles. So if we go to the next slide, please. Now, these are the basic operations that we are anticipating. And something that we didn't mention, or I didn't mention, and Mark didn't mention, is that Mark also is acting under UNR as the test site operator for this Nevada Autonomous group. So basically, all these type of activities is what we're expecting for 2023. And I'm not very much entitled to talk about the COAS, but I want to just give some overview of what we are planning to do, which is how we're going to work with the FAA to get authorization so companies can come and have different type of activities in the state of Nevada. And we're looking at companies from the state, outside the state of Nevada, and international companies that may want to come and do some work with us. Next slide, please. These are some of the technical capabilities that we have at the university, and we're not limited to those. I mean, it's just to name a few, but we are doing a lot of drone integration. This is a very multidisciplinary set of technologies that it requires mechanical engineers, deep learning programmers, artificial intelligence, computer science, cybersecurity, and many more. Next slide, please. And what about the skilled workforce? And what about beyond UNR? Our mission as Nevada Autonomous, even though we are under the University of Nevada, Reno, our goal is to create an ecosystem in the state that will integrate and bring faculty, students, and capabilities from all the other NC Nevada System for Higher Education groups that will include the UNLV, CSN, TMCC, and DRI. They all have drone programs, they all have drone capabilities, and I think when an operator or when a company wants to come to the state of Nevada, we cannot limit the resources to just one academic institution. We want to be able to open this to any collaboration. Now, how we're going to do that? It takes a lot of work on bringing faculty and students and integrating these programs and keeping the communication alive. So right now we're focusing on UNR and trying to get, this program is 3 months old, and we're trying to get everything in line so we can move into a statewide type of operation. But that is the goal, and that's where we're going. Next slide, please. Industry partnership is something that we are doing, and we are moving forward in that direction. Our first solid partnership is with Iris Automation. We are working with SafeFlight, and our friend John is here, and he can talk more about what we're doing together. But basically, Iris Automation and any other new company that we may bring into a close collaboration is basically to be able to provide capabilities and services that are beyond our own capabilities. Again, when a company or when an agency wants to do some testing in the state, we don't want to limit our responses to them to the capabilities that UNR or the Nevada System for Higher Education can provide. If companies can provide some resources and services, why not? We are going to collaborate with these companies, and we're going to just get this collaboration ongoing. Next slide, please. Now, this is a lot of work. These are probably some of the companies that we identify in the state of Nevada. Probably there is more at this point. This is an ongoing process, and we figure that 43 companies is more than enough work to do in the next couple of years to start touching base with them and talking and trying to see what capabilities they can bring to the table and help the economic development of the state of Nevada and our mission as a test site operator. Next slide, please. Now, this is not a company, but the Nevada Autonomous Group is trying to complete a new partnership with the Nevada National Security Site. And basically they have a self-contained international and non-US citizen will need clearance to get into that unrestricted airspace and restricted airspace. And basically we want to be able to offer companies or agencies to come and do some testing in that facility, in that location. Next slide, please. Now, some of the current projects, we can mention Andra Technology. We're doing some remote ID solutions. This is our first competitive grant that we got in the 3 months of life that we have, that is coming from the FAA. So we are subcontractors for the Andra Technology Group, and we're working on this project. Safe Flight Corporation, as I mentioned, we are trying to get different grants opportunities and work to do on low altitude interagency communication response and reporting. It's a very interesting program, and we are trying to get more off the ground with this. There is a company called Aerobic 7 from California is trying to also do a low altitude mine detection, and we're working with them to do some work here at the state airport. And the NNSS that I just mentioned, we are doing some program, or we are in the beginning of a contract that will do low altitude mine detection. GPS denied tunnel exploration. So basically they have several tunnels that are on site, and these tunnels are being closed for quite a while. They want to send drones or robotic equipment inside to map the tunnel and basically see the integrity of it as a phase 1. Phase 2, if the integrity is good enough for them to go into a phase 2, will be to send again drones with sensors to detect different type of radiation and make sure that the area is clear. And so if phase 2 is done, that will be a successful phase, and then there will be more tunnels to do exploration. Precision AI is a company in Canada that we started talking, and so basically they want to do crop dusting. In here, this is my 10-minute warning because I have the tendency to talk too much. And I have 3 dots because there are other companies that we started conversation. We are looking at potential collaboration. I met with 7 companies from the Czech Republic during the UAS Expo in Las Vegas. Some of them are interested to come and have some operations here and basically expand their market capability into the US using Nevada as the initial step. Next slide, please. And finally, this is one of the good things that we have at the university. It's called the Robotic Arena, which is a large high bay with a tall ceiling that can be utilized to drone testing, and this is indoor testing. The arena is surrounded by cameras, and you can get a 1 millimeter precision of the location of the drone. We have mattresses on the floor, as you can appreciate, so we have a soft crash if the drone is failing, and a bunch of boxes and areas that we can do some different type of scenarios, so the drone can fly and do some detection, and it's a safe environment that you do some specific testing indoor before you move your drone out on the real world. And on the next slide, we have some capabilities for the robotic arena. I don't want to go one by one on those, but it's a very precise environment, and also it's unique in the United States because there are only quite a few of these characteristics. I think that's the end of the presentation, and I will be open for questions with the rest of my colleagues.
Thank you.
Okay, thank you.
Just before, or last week, I believe it was, just before our program, I learned of a company here in Incline Village, John Abbey and Safe Flight. So I wanted to give him a few minutes to tell us about Safe Flight. Please, John.
The good news is I don't have any slides. But that could be bad news. Matthew, I have a perfect research project for you to continue your great research. And I think you ought to start delivering Mofo's pizzas. Do I have a yes from the crowd? You would get tremendous support here. Excuse me.
Interestingly enough, that was going to be a dinner choice for us today. It's funny you bring that up.
Okay, so just like pizza, there's a downside to just about everything. And addiction to pizza is definitely a downside. Oh, I've got a slide. Anyway, we've heard some great things here, and there's tremendous marketing potential with drones. It's just endless. And from a public safety standpoint, and I should mention that I come from a public safety background. I'm a retired police chief from Silicon Valley. Before I moved up there, I was in Southeast Los Angeles policing for 20 years. So that's my focus. I'm not an engineer. I'm not a pilot. So I want to talk about the regulatory side, and I don't want to do it in real scientific terms. I want to talk about real life issues that we encounter. So this is kind of the challenging side of developing what's been called the UTM, or unmanned traffic environment or structure for the world. When we talk about regulation, we really have to start about 123 years ago, if my math is right. A poor fellow stepped out of a streetcar on Central Park South and was hit by a horseless carriage and became the first traffic fatality in the United States. Henry Bliss. Can't forget Henry. The problem with looking back at that occurred in 1899. It wasn't until 40 years later that we actually started having traffic laws that were uniform, other than just city ordinances, don't drive too fast. 40 years to come up with signage on the highway. that was consistent between California and Nevada and New York and every place else. So it took 40 years for the regulatory structure to be developed on ground-based transportation. Okay. So what we face now, well, the other side of that, so we talked a little bit about ground-based traffic enforcement and traffic management. Carlos mentioned below 500 feet, or above 500 feet is really where the FAA focuses all their technology, and all their safety regulations are basically written for 500 feet and above. We have the new drone world, which is 400 feet and below. And so the problem with that situation is that since I've been involved in this, there's been about 3 million drones sold and in the hands of just hobby operators, a vast majority of them. Most of them are unregistered because they were purchased before the registration process began. The number of drone incidents that have occurred in recent years is dramatically increasing. And that's kind of a general statement. Let me give you some facts. The last actual reporting that I'm aware of from the FAA is that we have about 3,000 incidents a year where drones get into the controlled airspace of airports and other various violations of flying drones in the wrong place. Well, over the past few years, we've been doing actual research with drone detection at airports. And we came to the realization that 3,000 is probably dramatically undercounted, because in June of 2020, at the Los Angeles International Airport, in June alone, there were 1,200 drones that were detected in the approach and takeoff areas of LAX. So I think that's probably the most important thing I could say is it is a real problem, because the most vulnerable part of aviation in general, and in this last 2 weeks, I've flown, I don't know, 15,000 miles. The most vulnerable time in flight is landing and takeoff. And the fact is, and there's always arguments about, can a drone really take down a plane? Well, a goose can take down a plane. I mean, imagine that drone or that drone could down if it's sucked into an engine on landing, when it takes a few milliseconds for anybody to respond. It could be a fatal collision. So this is a really important thing. So now, what does SafeFlight do? About 7 years ago now, is that my phone that keeps beeping? I apologize. About 7 years ago, I was involved in the drone legislation in the state of Nevada, Carson City, and the legislature ended up passing the first real drone legislation in the country, and it turned out to be focused on law enforcement and restricting law enforcement on how they can fly drones, and mainly the evidence that can be used, used appropriately in the case of something that's collected by a drone. That's something I'd be more than happy to get into great details, but it's very limited. Right now in the United States, 85% of all law enforcement agencies, that's 18,000 agencies, 85% of them either have drones or they have reported that they plan on developing a drone system. So that has become a very, very important part of the whole drone world. But to deal with the challenge of the drones that are flown by, and everybody here knows this, by the clueless, careless, and criminal elements. I mean, that term's been used like 1,000 times in keynote speeches. The challenge is that you can detect a drone, a pilot can report a drone to the tower, but there's no connection between the tower and the people that are actually going to respond. So what we do, and this is kind of the end of it, is we've developed the protocols. Actually, you're from Y Combinator. I'm a TechStars guy. So we spent time with the United States Air Force at the Air Force Accelerator in Boston and developed the protocols to connect air traffic control, 911 centers, and actually the officers on the street that are going to respond to these calls. Right now, according to DHS, we have about, 2 years ago, we had 249 companies or 249 solutions that detect and defeat drones. So there's plenty of drone detection companies out there. Certainly more than 250 now. Not one of those companies can effectively get what they detect down to the officer that has to respond. So what we do is we have a 3-tiered system that works at air traffic control, 911 centers, and then on the officer's cell phones or tablets or mobile computers. And we can take a detection all the way through the cycle and actually complete a comprehensive incident report that goes to the FAA so that they can take action or or warnings or whatever they're going to do. One other thing that I wanted to mention, and this is part of the project that we're doing with UNR, is that it's not only airports, it's not only the approach and the departure from airports, but we also have a huge problem with drones flying over wildfires. And the rule everywhere, every agency that I know of in the country is if they fly, we don't. On almost every major fire, every one that I've looked at, there's been a period where the attack planes, the fire attack planes have been grounded. The rescue helicopters have been grounded. I just heard last week, the FAA has 12 confirmed collisions between drones and helicopters. Most of those are medevac helicopters. So this is a real problem, and the only way that we can solve it is to have a nationwide law enforcement network using the 740,000 cops we already have. So that's what we do, and I'd be more than happy to answer any questions you have, but I'll give it back to everybody else.
Thank you, John. Anyone like to start off with a question or the second one?
I'm sorry, at least just with regards to the SkyDrop, you were mentioning, the Incline, there are thousands of packages from Amazon. I hate to hear when the builders do drones with one drone, doing pictures. What's going to be like when you have 100 or 200 or 300 drones in an hour delivering packages on the street? I mean, have you considered the whole noise pollution component to the
Yes.
and just kind of those things?
Yeah, no, we have. So is the question about noise?
Well, my question is, it's almost like swatting flies. It's going to be a nuisance at some point. I mean, you have a truck that can carry 200 packages at a time. Is it efficient? Maybe not. But now you have 200 drones flying above you.
Yeah, let me answer your question in 2 ways. One is generally, two is specifically. Generally, I'm sure when Henry Ford made the automobile, there are a lot of people saying these things are going to make noise, it's going to be a terrible world. No, it made the world a whole lot better. Okay, that's the general answer. The specific answer is that we've built our technology to hover and lower from 200 feet, because at 200 feet, it effectively blends into the ambient background noise. It is quieter than a delivery vehicle pulling up in your driveway. Now, that's us. Certainly, I know that Google Wing has had problems with noise because they have aircraft that deliver from a lower altitude, generate a louder noise, and that noise is at a higher pitch. So I think that the companies that are proactive and thoughtful about this can preempt the problem.
Good question. So the drone that I purchased is made in China. I know most of the commercial hobbyist type drones are made in China. Do you think it's important for the US to develop its own drone industry?
Yeah, I think that drones are asymmetrical warfare, right? I think you have a small number of them and they can disrupt, drones beat tanks. Anyone who's been watching Ukraine, footage out of Ukraine knows that, $1,000 drone often beats $1 million tank. And so when you have something that is critical to national security, it's important that it's domestically produced. And America has until now objectively been losing this battle because of the 1 million drones that every Christmas that are sold, I think upwards of 90% of them are made by DJI, which is a Chinese company. And so I think it's critical to national security that you have domestic manufacturing of drones.
I think that's cuts across a wide variety of things, right? That Congress has passed some laws to increase the likelihood that the chips are manufactured in the States. We all heard that book, the World is Flat. We took advantage of manufacture something relatively inexpensively somewhere else, transported relatively expensively to here or other places just in time. But we found during the pandemic that may not be necessarily as good when the chips are down. So I think, and then there's other, just as Matt alluded to, security concerns. U.S. government, at least at the federal level, has basically not allowed companies to use DJI drones for a lot of federal work because the technical concern is that information associated with that mission or how that drone is flown, we don't have control with where that data goes. And so there's concerns that the Chinese could be taking advantage of that. So for a lot of good reasons, my grandchildren are not going to work in China, and I like to have them great jobs here in the States. We have significant security concerns with our own infrastructure and being able to protect that. And then finally, just across the board, I think that while the world is flatter, there are still logistical challenges that can be best solved by producing products here in the States.
Yeah, and one last one to add. There are a lot that can be added, but one last one to add to that is quality control. I mean, we have our facility right here in your backyard in Reno, the manufacturing facility where this eagle is made. And we believe that gives us the ability to have, to achieve much better quality control.
Yeah, I don't blame you. We take the same approach. We manufacture our technology here in Reno. So yeah, for some same reasons.
I just wanted to add one thing about you said that you were DJI. The challenge with DJI at one time had 85% market share in hobby drones or small drones. It wasn't the fact it was a Chinese company. There's nothing wrong with Chinese companies. As a matter of fact, just about every robotics company in the United States, besides maybe Boston Dynamics, the products are actually made in China. We have no problem with that. The US military had no problem with that aspect. But in the case of DJI, they had a very unique design on their licensing provisions and the way they handle their data. If you buy a DJI drone, you sign all of your privacy rights away, because the way that their whole business model operated is every aspect of your operation, from the time your drone takes off until your drone is turned off. They are recording that process, and they're recording it for all kinds of reasons. But the problem was that became available to people that are not necessarily friendly with the United States. So that's the downside, and that cost them all their military contracts. The upside of it is actually I think it was the day that we got authority from the FAA to go to all the airports. A drone stopped a baseball game in Boston, and it was a big deal. I was in Boston at the time, so it was a really big deal. Well, they identified that drone, and they had the person who was like a 14-year-old. They had him in custody within hours because he flew a DJI drone and all of that information. They knew exactly who owned the drone, who bought the drone, who was operating the drone, and they had the whole flight path over the Boston Stadium. So there's two sides to that, but it cost them their presence in the United States. But now their detection business is making almost as much money as their drone business, because we've got so many DJI drones in the air that just about every airport, every critical infrastructure site in the United States will have Aeroscope, which is a DJI product. And that data does not go anywhere. All the data is on the edge. So
I just wanted to chime in and agree. We happen to have a drone services and data company that's been around for 9 years, based here in this state as well. And we're totally agnostic about what the best solutions are for hardware, software, optics, all the gear we use. And DJI has been at the bleeding cutting edge of providing incredible solutions for that. But and you just answered the other part of the sort of data security question. But I think in the tone of today of where things are going, it's a wonderful, brave new world of what these breakthroughs in technology are enabling. Every time we have a new inquiry from a customer about, can you do XYZ, from the air of detecting data and interpreting it, et cetera. It's phenomenal of all of the startup companies and existing DJIs of the world of how many great solutions are out there, enabling or disrupting existing solutions or industries, but also bringing us amazing advances. I could go through a whole list of them, but I'm not here to talk about the specifics. I'm just basically weighing in on that. And as much as I'm a proud American, maybe the best solutions win from wherever. It's like we're in a global world, and we'll always be in that as far as I'm concerned.
What's the name of your company?
Above Geo.
Above Geo?
Above Geo.
Okay.
Another question about infrastructure. So I read an article in The Economist talking about a drone highway being planned in England, where there would be, I think it was using cell towers or some of the detect and avoid equipment that goes on drones can weigh it down. So this was more of a ground-based, using equipment attached to cell towers that would allow drones to see each other, communicate. I know with SkyDrop, you have plans to have kind of launch pads outside of shopping centers or things like that. What is some of the infrastructure that is needed to allow more commercial drones to do their thing?
So can I answer your question without answering your question?
Yes, please.
So it sounded to me like the question was like, what is needed that is not currently there to enable the industry to truly scale? Okay. Anytime we have meetings like discussions like this, I feel like there's an elephant in the room, and that elephant is the regulatory question. Congress mandated the FAA integrate drones into the National Airspace System in the 2012 FAA reauthorization bill. And I think that mandate was for the plan to be implemented within 2 years. So the FAA is now 10 years behind the congressional regulatory mandate and approximately 8 years behind the due date for that mandate. Okay. Now, this is an industry that is going to create billions, if not trillions of dollars in wealth. It's incredibly important for national security. And other countries are beating America because their regulations have moved at the pace of industry, not at the pace of government. So what is needed is regulatory solutions more than any kind of infrastructure. I mean, from my perspective, the technology's here, it's the regulations that are holding the industry back, which is why at SkyDrop, we've achieved nationwide regulatory approval in New Zealand for commercial drone delivery. And so we're going to be launching and scaling there first. Now, I would love to be doing this in Reno. I'd love to be doing it in America. But the objective fact of the matter is that other countries are ahead of America from a regulatory perspective. And we should all know that, and we should all talk about that.
Yeah, Matt's exactly right. The regulatory challenges is the 600-pound gorilla in the room. And has been, you know, we have provided tremendous amount of data to the FAA that shows our detection ranges, or the likelihood of properly classifying it. As I tried to demonstrate to you, we're far better than the human eye. And in fact, a typical pilot will only see 50% of the tracks that he or she should be able to see within our field of view. If we were against that standard, our technology would have been flying 3 years ago. But we're against a much, you know, the FAA doesn't know what the right answer is yet, and they're dependent upon industry to tell them what the right answer is. But yet, you know, human nature being what it is, they're slow to adapt, and they've been able to hold off the Congress quite a bit, because how does the FAA funded? Oh, it's 75% that's from user fees, and the FAA can happily say, well, it's a safety issue. So Congress is challenged to be able to push back, because they don't want to be perceived as being pushing something upon the FAA that's unsafe. They don't have nearly the budgetary capabilities to be able to force the FAA to do things that maybe other executive elements of the branch can do. So that's their challenge. So I think, you know, great companies like us and SkyDrop and others are basically doing our level best to demonstrate the value proposition, which is typically easy to show, but also that they can be done safely. And I think that's what we're pushing. The rest of it, the kind of things I want, these are all technological solutions themselves.
Okay.
A solid command and control link, the ability to be able to you know, detect and understand the rest of the aircraft and operate in a UTM so that everybody has a common operating picture of who else is flying in there. Building aircraft with appropriate redundancy and reliability and safety systems, so that even if it does depart controlled flight, it doesn't cause an undue risk to personnel around. That's the reason why Nishu alluded to the parachute system on the Eagle. So industry is working those things, and like I said, the biggest structural problem we have is the regulatory one.
Can I add to that, because this is fun?
Yeah. What passion the FAA?
Well, just objectively sharing what's holding the industry back. So I'm just going to use like I just want to make a point, which is that this is not rocket science. There are simple answers to the regulatory questions, you know, and let me just give you an example of one that Mark alluded to, right? And I'm not saying that this is the only answer, but it's a simple one, right? If pilots today can fly manned aircraft using their eyes, then there's an objective standard there. And if Iris's technology already exceeds that standard, why can't they fly beyond visual line of sight? You know, what's so hard about a regulator saying, here's the standard, if you can beat it with whatever technology you choose, green light, go. That hasn't happened.
I believe it's safety, and nobody wants to really get going with anything that maybe safety.
But I'm saying there is a safety standard under which humans can fly aircraft beyond visual line of sight today.
Yeah.
What's so hard about saying if your technology can beat that standard, go for it? No one said that.
Can I jump in here? And I agree with you, except the challenge, and I since for 7 years, I've been working with the FAA and DHS and all of these people because we're on the other side of the equation. The problem that everybody faces is not commercial drones. There's, I cannot tell you an incident where a Part 107, which is a drone licensed pilot, has done something drastic. I just can't think of it. Maybe some altitude violations or whatever it is. But all of these incidents that we see where tens of thousands of drones flying over airports, those are not commercial pilots. Those are not your pilots. They're not flying with your technology. There are people that launch their drone and they want to, I mean, I've seen some dramatic, and I'm sure you guys have seen the same thing, where a drone is over a plane landing. I think it was at Las Vegas. And so you see this dramatic picture of a plane landing. But then you think about, where did that drone have to be in order to see the plane come underneath it? I mean, it's scary stuff. But let me give you the good news. Good news for everybody is, I believe that, well, I can talk for hours about all the regulatory things that relate to where you can fly and who's going to enforce it and all that stuff. That's hours of discussion. But basically, we move very, very slowly. We got our authorization for all US airports in July of 2019. The problem is that the detection systems that we basically need to have as part of the whole dimension, the 2018 legislation, the FAA Reauthorization Act, said you shall test 10 solutions, 10 counter drone solutions in 5 airports, 2018. They are now in the first airport, testing all 10 systems, Atlantic City, and then they're going to move to Syracuse, to Seattle, and whatever. So that stopped the whole process. Okay. But somewhere along the line, and I don't recall the exact date, but the Airline Association and AUVSI, which is the drone organization that promotes, they're basically the drone organization. They had a blue ribbon task force that published a report on drones over airports. This was, I think, 2021 was last year. And that threw the grenade into the middle of Congress and the White House. So right now, we're within 10 days, every Part 139 airport, which is commercial airports, anybody that has over 10 passengers, all 550 of those airports have to have a drone response plan in place. And so that's by in 10 days, September 30th, well, less than 10 days now, but September 30th of this year, if an airport, technically, if an airport doesn't have a plan or they're right in the middle of it, they have to shut down. That's not going to happen. But based upon all of this, and I really track it back to a industry study that told them you have to do something. We are now operating under a White House action plan. And I'm sure you guys go to as many conferences as I do. If I heard White House action plan probably 50 times in one day of listening to keynotes and sitting through sessions. So it is moving a lot faster than before. And your life is going to be far different when there is, because you're in the transportation business. You're like UPS, FedEx, or whatever. How would UPS and FedEx be able to deliver if there was no enforcement on freeways and surface streets, if it was just a free-for-all? I mean, that's pretty scary. That's what we face right now, is your highway is not enforced. Anything under 400 feet, the FAA has no structure to do it. I met a special agent. Just inside baseball here is the important people that carry guns in the federal government and law enforcement are called special agents, FBI special agents. I met an had dinner with an FAA special agent the other night. And I said, how many, you've got 550 airports. How many special agents do you have? He says, I'm one of 16 in the entire United States. So that is the drone enforcement system right now, is 16 special agents that are across the 5 regions of the FAA. So things are dramatically going to change in the next year. And they built in a waiting period that, and in fact, Carlos was kind enough to send me the legislation as soon as it came out. I'm sure you guys have seen it, but it's a bill that's this thick, and it's the It's the 2022 Drone Act. And that is going to dramatically change things. It gives DHS, the Department of Homeland Security, authority to designate police agencies to respond to drone incidents. So the whole thing is coming together. Something I've been working on for almost a decade is all going to happen probably in the next 18 months.
That's true, that legislation is changing the game a little bit in the next couple of years, and one of the good news is that in general, legislators are pushing FAA and laws and mandates that encourage the use of drones for different activities. The latest one before the one I sent you, John, is 3 or 4 legislators encouraging the FAA to work with companies that will do bridge and infrastructure inspection using drones. So I think it's coming. The question is, it's going to take another 10 years or in the next couple of years, we're going to see real changes.
I hope it's in the next 18 months because I'm getting old. I'm not going to make it. I'm not going to be working in 10 years.
Well, the challenge is for many startups because you fundraise and you have a runway until you can scale. And so, I think the frustration that you hear from these end of the table is that as you're waiting to scale, that's a challenge when you're trying to build and keep great people in an industry that we have been building to date. So that regulatory leap is important. I'll be candid. I have yet to hear a regulator of the FAA say the reason why you can't do X, Y, and Z is because somebody's flying a recreational drone in an unsafe manner. So it's a bit of a revelation to me, but if that is what puts us over the top, I'll be grateful.
Well, I just probably can't say much about this, but there is a university that's strictly in the aeronautical business that we may not name that has drone detection in dozens of airports right now. And the data is not going anywhere other than to a company to analyze it, put it all together so that it can be published somewhere down the line as an academic research paper. The problem is it's proof positive that there are hundreds of thousands of drones. And all I talk about now is approach and departure of airports and wildland fires. I don't talk about the drones that are flying over. I mean, the sheriff of Douglas County was telling me that every time they have an event at Harris or Edgewood, you have to swat the drones that are in the air, particularly when all the star football players show up for the golf tournaments. So the problem is one that is just sitting below the surface, and when it finally happens, and I was shocked to hear that they have 12. The FAA has counted 12 verified collisions between hobby drones and helicopters.
How many fatalities?
I have no fatalities that I know of.
Right.
But
Can I make just one kind of additional point? I think a lot of what we're talking about here is theoretical. The point that I want to make is it's not. So let me just put a number on it, okay? About 350,000 Americans have a cardiac arrest every year. So a really, really conservative estimate is if you had drone delivery of AEDs, of defibrillators, which Nishu spoke about, stationed all around the country, conservatively, you'd save at least 100,000 lives a year, okay? I just made the point that the FAA is 10 years behind the congressional mandate that asked them to develop a plan and integrate drones into the national airspace system. 1 million people are dead who might not be dead if the regulations kept pace with industry.
Folks, any other questions? Could we wrap up with just something that's next step or coming down the pike that you're excited with? Anything coming up with NCAR, Carlos, that you'd like to share?
Well, as I mentioned briefly, our next step will be to create a comprehensive program integration for the state of Nevada, where industry, academia, and government can work in harmony, good collaboration. It seems like a blue sky approach, but we're doing that in smaller scale. And once we prove the concept and we have enough agencies and companies on board, I think is, the famous, if you build it, they will come. We create the environment and then try to keep moving forward with that. So that's what keep us moving, and there is a lot of work, paperwork, rules, regulations, bureaucracy in the way, connectivity with FAA, bring the regulations to the researchers, bring the researchers to the companies. So it's a massive approach, but I think it's doable. And again, if we start in small scales and we get the right number of people on board, I think it's the right direction to go. That's what keeps us excited.
We're particularly excited about the fact that we've been able to fly beyond visual line of sight using our technology as the only mitigation. Now we're working with great customers at their sites and their locations to be able to do the same. Despite the FAA bashing, we are seeing a much more of a willingness for the FAA to now take a risk-based approach and look at what the capability of our system bring. And so I'm excited about next year, because I think we're going to see a significant uptick in our technology being deployed to great companies like SkyDrop and others to do drone delivery or drone in a box kind of companies, again, to be able to respond to emergencies and things like that. So we're very excited.
What about SkyDrop?
So I'll let you talk about the inflection point of the industry. The one that's dear to my heart right now is the commercial trial that we plan to do before the end of this year in New Zealand with Domino's. And that's what the team is focused on right now. We have very active engagement with all the executives and the operational team of Domino's in New Zealand, working with us to launch this commercial trial, given that we have the regulatory approvals over there. So that's definitely going to be a big, we know we are designed for market fit, as I was telling you guys, and now this will be the next step validation through this trial.
Yeah, very well said. I think proving product market fit leads into scaling, which means that this industry is about to take off. It's been a long time coming, and I'm going to be really excited to see it take off.
So how far are we from getting pizza delivered across New Zealand, or when will that become a really common thing?
There are people who live in New Zealand who can have pizzas delivered by drone within the next couple months.
Yeah.
It's very exciting.
And then Reno will be next.
I certainly hope so. Yeah.
Incline needs to be next, mofos. I'd be more than happy to take you there. They're still open, you can go right now, you'll be sold. If I could just add one other thing, which is with Carlos. We currently have a memorandum of understanding with the 152nd Air Wing of the Air National Guard. We have all of the law enforcement agencies, the sheriff and police departments in Washoe County and 2 other counties that want to join it. We are going after an Air Force grant in October to have the world's first comprehensive drone enforcement system here in northern Nevada. And after we have that, and we're going to take it to southern Nevada, and then can I retire?
You can, but we'll take to the rest of
I'm
the
going
US.
to retire and become a professor. So that is really good news, because we could talk for hours, but you wouldn't have the industry of the United States if safety and enforcement weren't just a given. If you own a trucking company, you don't think about the fact that your trucks are so much safer on the interstate because you've got the NHP or CHP, as much as we don't like to see them behind us. That's how our systems operate. Is you have to have the system that provides the safety, and then you guys do great things.
I find it interesting that you came to the US to build this company,
but you have to leave the US to use the company.
Interesting is a good word.
And I think that's, you know, what, it's an odd juxtaposition. I'm glad that we have the brain power that brought you here, but you know, New Zealand is a small country and the US is so large and diverse, and you know, it's like moving the Titanic to do anything. But I think it's great that you can go to New Zealand as a small company and use them as, not use it, but use that space to work out some of these details so that you can prove to the FHA and Congress and everybody else that, hey, this can be done. So kudos.
Thank you.
Is there anything we can, like, should we be writing our legislators that things need to change or change faster?
Repeal the Nevada drone law. It's absolutely insane.
So the Nevada drone law is kind of insane, but that's not like the root problem. The root problem is having, you know, federal regulations that enable industry to flourish. And so, yeah, you should be doing whatever you can do to help make that happen.
Is it because they're trying to lump all drone flight into one instead of commercial, you know, private hobbyists? It feels like they're trying to do this gigantic comprehensive regulation that's slowing everything down. And it seems like they should be concentrating on private even more, because that sounds like the hobbyists are the ones causing the most issues.
But definitely we can learn from other countries. Your approach with New Zealand and Czech Republic is very advanced on legislations, and the one that I believe is going to be the first country that will have drone urban mobility. It's going to be South Korea, and they are very advanced on that, not only on the technology, which is cutting edge, but also on the legislation. And the president already said that they want to be the first, and I think it's coming. So we're working with them. We have an MOU with Seoul National University, and our goal is to learn from not only the technology, but how they're planning to do these things.
Nice.
Well, I want to thank you so much for making the trip. I really appreciate you coming up here to share your expertise and knowledge. It's always amazing to find out what is going on in our area. That's one of the reasons I love living here. It's pretty cool stuff going on. Thank you for attending tonight, and thank you all once again.
Thank you.
Thank you.
Thank you so much, John.